Okay, welcome to today's video. We will be working on the DCC board that goes inside these PMD2 cabinets. This is one of the older generations. You can tell that because it does not have a switch. It's not the oldest generation because it does have these style transistors on here instead of the can style ones. There is an older generation of this board. So just kind of a brief overview of what's going on here. So this spot that looks like it's missing something, it is missing the RSO board, but they don't use RSO on any of their PMD2 cabinets, so that's why it's not there. I do have some of the RSO boards, but if they're not going to use it, there's no point putting it on there and, wearing it out by having it installed when it's not being used. So a brief overview of what's going on here at this plug. We'll just go over the important ones. This is your 12-volt ground. That's an input to this, and then this is pin 14 and pin 10, so 4 down from it goes to the fuse there. It is your 12-volt positive coming in, so that way if you wanted to bench test it, you would get power to those 2 pins. And then what this thing produces, you get a negative 12-volt rail, a positive 12-volt rail, and then you still have the common, which would be right there. So your positive 12-volt rail is pin 6, so you just count up from here. So 1, 2, 3, 4, 5, 6 is your positive, and then 7 is your negative 12-volt rail. But again, that's not ground, that's negative 12 volts, so it's 24 volts of potential energy between the two there. If you were to probe it like that, but you should probe from your common and check your negative 12 volt and positive 12 volt once you have it working. So this one, what we can see wrong with it just from visual inspection is there's a little wire here that is just blown up and gone. And then you can see that there's been a lot of heat around this transistor. So probably have a bad transistor there. So let's just give them a quick check here and see if we have a dead short across them. No dead short there. No dead short there. No dead short. I keep hitting that leg, so no dead short there. We do have a dead short across it that way. So yeah, one of these two guys are probably bad. I'm going to take a hint and guess that it is the one that has all the heat damage to it. So we'll go ahead and remove that from the board. All right, so let's get the screws off of it. Okay, so yeah, as you can see, we no longer have that dead short across it. While the dead short still exists on this one. So bad transistor, easy guess from the heat damage. We're gonna go ahead and just replace both of them though, because I have the parts, they're cheap enough. Just get them both while you're in there. Okay, so now we have both of those off. Now we have to repair this. So let's get down here. All right, so we got that off of there. And you noticed that one kind of got glued itself on, so that was a pain to get off. First time I ran into that with these. All right, so let's get our enameled wire. And yes, heat and flux will break down the enamel wire enough to get it to work. I just like to kind of prep it a little bit with a little scrape there. All right. I guess eyeballing it, I cut it a little bit long. Oh well. I'll just trim the excess off from the bottom. Okay, so yep, got the cable fixed there. Now we need to put our new transistors on. They are a PNP transistor. This is the first one I've seen like this where it didn't even have thermal grease on it from the factory. Most of them do. So yeah, got some thermal grease, just some cheap stuff, but it works. I hate working with this stuff. It gets on your hands, and it's always a mess. Only need a very small amount here. All right, and then our two new PNPs. So they actually get their ground signal from there or there, whichever way. Which way? I'm looking at it upside down. There we go. Yeah, it goes there. So we trim off that middle leg, just like the old ones were. And these are the exact same one. They're just a little bit newer, so they're lead-free. Instead of the old ones were not. Okay. All right, let's solder these back down. I am seeing a small problem from when I desoldered it. They made some little trails there, so we'll clean that up too. So let's clean those up first, and so I don't forget. All right. Okay, now let's solder these down. Okay, now we can double check that we solved it. So no more dead short across there. Yep, no more dead short across there. So we can go ahead and put this in the cabinet and actually test it and see if it works now. Okay, so this is the PMD2 cabinet if you haven't seen one before. The DC board, we already got one in here. Yep. Take that one out and we'll test this one in it. All right, so we're pulling the normal 1.2 amps as it powers up. We are getting our RX and our phase. Let's just give it some time and see if the MD light comes on. That one takes a little bit longer to turn on. These things make this really weird noise. All right, and there we go. MD light's working. So everything's working properly. The RSO light obviously would never come on because it's missing the RSO board, which this one actually has it on here. So it's not wired up for RSO either. So yeah, wouldn't come on even if it had the board, because it has to be wired up for it. So yep, this one is now a repaired power supply, so we can put this in the fixed parts pile. But yeah, they're pretty simple to repair, pretty simple to test. Really the most common problems are either dead tantalum capacitors, some of these guys right here, or the transistors. And when one of these transistors blows, it always takes out that little strip of copper wire. And yeah, this is a slightly newer one. So this one is date coded 1992. The one we were just working on was date coded 81. Well, I hope you guys enjoyed this video. If you like seeing the train stuff, go ahead and comment down below in the video, and I'll continue to make videos on this. I know maybe not quite as practical video as my other ones. Not quite as many people will be working on these, especially something as old as the PMD2 cabinet. I mean, these things are, I believe the earliest ones were made in the 70s. So yeah, it's pretty old tech, but it still works and it's still in service. And especially, you know, this is 1981 on that board that just repaired. Now, this cabinet is set up different than the other ones. This is what's called a single island cabinet. So normally you'd have 3 cards in the 3 island cabinets. This one just has the single RSI card instead of, let me see the names of them. So yeah, you have an RSI in this one. Well, you'd normally have a ISR, STC, and IST in here. This one can be set up either way. These ones, the older ones, I have another, here, let me pull the cabinet into your view. So this one is a 3 island, and it also is only drawn out on here to work as a 3 island. So they want me to see if there's any way to convert these 3 island ones into a single island. So I am going to look into that, and I'll do videos on it. But yeah, this one is slightly older. And it's my first setup. So these are set up where you notice like half of it's empty. That's because you can have a master and a slave in here, and so that I only need to populate half of it for testing because it's only ever using half of it, and it can switch between the two. So yeah, and that's the difference in the PMD2 and the PMD1 cabinets. The PMD1 cabinets, they're just half of this. So you know, and the PMD ones are the original ones of it. So there is one other thing that you'll notice, all these extra wires coming off of there. They're going to the inductor here, which is a dummy load that shows the dummy load's just a train track pretty much. So it just signifies different levels of train track. That one is date coded from the 70s on there, so that dummy load's pretty old there. But yeah, these are 2 different styles of the PMD2 cabinet, and I've been primarily working on these. This one just got dropped off yesterday for me to start looking at some of these RSI boards. I have a bunch of the RSI boards that aren't working. I might do a video on the MD cards because I actually repaired a few of these MD cards last night. I don't know if I'll do a video on them though, because they are kind of complicated cards, and it's been kind of random problems on them. There's not just one problem I've been seeing over and over again, so the diagnostic process takes me a couple hours on them. So we'll see. I may do a video on one. I'll probably pre-game that video if I do and like diagnose it beforehand. But that power supply that I just did, I did not pre-game it at all. That was just an on-the-fly repair there. So I hope you guys enjoyed the video. And like I said, if you like seeing the train stuff, if you want to see more videos like this, I can do them, just let me know down in the comments, and I'll do some more videos on it. But yep, I'll see you guys in the next one.